Second. Okay, so today's meeting, Wednesday, 6th of April, I guess the two things we were hoping to talk about were data from Lee's lab, and then compounds from Daniel and potentially from Maria. So thinking about what we might be testing next and potentially last before we try and write up the paper. So those are the two things today, really. And so Lee, Tom, did you want to dig right into?
Yeah, I've prepared some slides just to go over really quickly. As you'll see, this has taken a lot longer than we wanted, of course, with COVID and everything. But I think we're turning the corner. I feel like there's a few things we'd like to repeat, and I'll talk about that. But I feel like maybe we're getting some insight, and I'm hopeful anyway. So let me go ahead and share my screen. Okay, I'm just going to start from the beginning here. Let's see. Okay, so you guys remember we're using these MIBS beads to try to capture all of the proteins that we potentially could, either ATP binders or kinases, and try to use this as a way to understand what potential targets for these compounds 26 and 28 might be in MRSA. Everybody see that okay? I hope that's good. Right, and the idea that we're adapting our approach to is the competition assay, where basically we incubate with the compounds and then ask if we compete binding to the inhibitor beads and look at subtractive analysis, basically, if we've competed off something. And we try to do it in a dose-dependent manner. And we've used this quite extensively to determine kinase inhibitor selectivity in the past. So if you remember the first attempt, we got a MRSA lysate. We weren't very happy with the results. It seemed like we were struggling with enough MRSA lysate. So we were also concerned if the assay was working properly. So what we did, I should just reiterate the goals of the project were to profile compounds 26 and 28 in MRSA, and then also to profile 26 and 28 against the human kinome. And as I said, because we were struggling with our initial analysis of the MRSA data, we weren't sure that everything was working. We turned to our standard approach, which is the 293 cells, and that's what I'll show first. And remember, from that data, we compared 293 cells to a known kinase inhibitor, dinaciclib, and we asked, were there any particular interesting kinases that were competed as a result of this incubation? So basically 293 cell lysate, incubate with a compound briefly, and then pass it over the beads and look for competition. And so not unexpectedly, with the positive control dinaciclib, we saw dose-dependent inhibition of CDKs like CDK9, CDK5, CDK2, and others that were specific. And these weren't affected by either 26 or 28 to any great degree, which again argued for the specificity of the assay. What was interesting was when we looked at what kinases were affected by these compounds, there were 28 specific responses, and those were shown here. One of them was a casein kinase, which showed some dose-dependent response, showed a pretty strong response. 2 NEC kinases, and maybe Lori, I don't know if these were somehow originally designed to be NEC inhibitors, but the NEC kinases came out fairly strong. And then the one potentially important off-target effect was TGF beta receptor 1, which showed a strong displacement after treatment. And none of those showed much of an effect with 26, which kind of argues that 28 may have some specificity for kinases. And this just shows you, again, the NEC difference here, NEC2, NEC3, both we were missing the lowest concentration in this experiment. So we had the 0.1 micromolar and 1 micromolar, but both of those showed pretty strong displacement, particularly with NEC2, where we didn't see that effect with the 26 compound at the same concentration.
So the thing on the right there is 28, right?
Sorry, you're right. Yeah, that has perplexed me before.
Yeah, sorry about that. That was
yeah,
mislabeling on my part.
the point is that, we have an assay that works. We have some insight. As I said before, I'd like to repeat this experiment so we have at least 2 independent verifications of this, because I think it could be important in terms of what the specificity is and what the potential effect on human cells is. Now, most recently, as many of you know, the bottleneck has been getting MRSA lysate. And fortunately, we found a lab next door, Brian Conlon's group, who was kind enough to get us MRSA lysate. So Kareem set up the experiment. Kareem also is known as Thomas. And he showed pretty good results in this last experiment, I think. And what I did is I didn't put all the data in there. What I did, he and I went through and we just said, what were 28 specific responses? What were 26 specific responses? And there were a couple that really stood out. And whoops, let's get back here. One was this protein ACP, which was specific to the treatment of 28, showed dose-dependent displacement. One was a translation initiation factor known as INFC. And then another protein was MNMA, which is an ATP binder. And so none of those 3 proteins changed significantly with 26, so they were very much 28 dependent. There were other ones that were 26 dependent, which I think we're not so interested in those, as 26, I think, is the control compound. But we were interested, and I did a little bit of research on these 3. And again, there were others that we could potentially tease out of there that were much weaker. These were among the strongest hits that were found. And so results, I would say, of the kinases, we can be pretty certain that we're seeing competition against probably casein kinase 1, the 2 NEC kinase and the TGFR beta kinase that I mentioned. And then in the MRSA proteome, we see competition against 3 proteins. This ACP, which is ACL carrier protein. It's involved in fatty acid biosynthesis. And actually, it's quite interesting that this pathway, some of these proteins related to it, are currently targeted for anti-MRSA drugs. This INFC, translation initiation factor, key regulator in protein translation. If it's inhibited, could potentially be important in terms of regulating protein translation in MRSA. And then this MNMA is a tRNA-specific thiouridylate. And like I said, it's an ATP binder. And there was a paper from a group in ACS recently that talked about this potentially being downregulated as a result of lactobionic acid treatment, which is being tested for MRSA. So all 3 of them have some credibility to them in terms of potential targeting. I think like I said, what I'd like to do is then figure out how do we move forward. And I thought I had another slide here. Let's just see. There we go. What happened to my other slide? Oh, there we are. Future directions. Yeah. So I think the first thing we should do is repeat our ATK 293 kinome analysis, just to get better, values on everything again. So we can say for certain that we think these kinases are likely to be targeted by the 28 and not 26. I'd like to repeat the MRSA experiment one more time. We can get more MRSA lysate from Brian Conlon's group and just go ahead and repeat that and see if we see the major targets repeating. And then I think what we need some help from other people on the team is how do we validate some of these targets? We could potentially do some pull down experiments and validate binding by Western blotting. There might even be some avenues for knocking things out, or maybe we just leave it as this is the data we have and we report on it with significance and statistics. And so I feel like that's a prerequisite, that we need to have that just for certainty, that we can be with confidence, say these are the major hits that we found, and then work on putting the paper together. So, we are working on a lot of projects, but I think this wouldn't take us that long because it's only 2 compounds, and we did hire a new person to kind of help with this project and other projects in the lab. So that's really all I have to say. But I think, like I said, I think we are making progress. I'm very pleased by the quality of the data that Kareem is generating. So many thanks to Kareem. He's really carried this project all the way through. Thanks to Brian Conlon's lab for stepping in and getting us MRSA lysate, which is not easy to do. And then Laura Herring and the proteomics group for running the analysis on this. And happy to take any questions or comments.
Great, thank you, Lee. That's fantastic. So yeah, the two repeats there that you're talking about, are they, I mean, given that they're repeats, are you able to do those in the reasonably short term? I mean, how's your pipeline looking of experiments that you got to do?
Well, we're extremely busy, as you might guess, but this wouldn't take Kareem that long to do those samples. As long as I have to talk to Brian Conlon's group and see how quickly they can get us more MRSA lysate. They were fairly quick once they got their lab back together. But I'll just have to check and see what the time. We have tons of 293 cell lysates in the freezer, which we can break open and do quite quickly. And Kareem might even be able to get our new person to do those experiments, but I actually probably have him do it just because he's more experienced. But yeah, that's what Kareem, you can do pretty much that in a week's time, depending on then what the analysis time is on the mass spec, which has been fairly busy, but not terrible.
Yeah, I mean,
sorry, carry on.
No, it's yeah, the bottlenecks are getting a hold of enough material to do the experiment and getting stuff into the queue for mass spec analysis.
Okay. What about the so the kinome analysis? Is it possible or helpful to go after repeats just against the hits that were found rather than everything else?
Well, we could, but in some ways I'd like to just go ahead and do the whole thing again, just so that we'd have two completely independent experiments to say, you know, this is what we found. And we could certainly then, I'm sure David Drury has NEC and antibodies. We could do some simple experiments to see, you know, just competition binding or something with an antibody to validate that. It would make a nice figure. The TGF beta R1, I don't know what you think about that. And I suspect we should pay attention to that as well, since that was a pretty strong hit. In fact, that was the strongest hit we had. And it was clearly different from 26. I mean, 26 didn't touch it.
Right.
So in terms of biology, I don't know what to make of that either. But and maybe Lori, can you tell us more? What's the origin of these compounds? Are these things that you made? Has any other profiling been done against them?
Matt would be the one to speak to specifically these compounds.
Okay.
I don't know as we actually know what the original target is, right, Matt?
No, yeah, we don't. I don't know what they were made for. I forget. These came from David Drury and Bill Zurcher's project. Bill was looking after them initially and developed the first hits.
Well, I know they have a great interest in NEC kinases, so it wouldn't surprise me if they have some NEC effects. There are other kinases in here that did show some response that might be important. PLK, PKA, there was a little bit of a response. And I think if we just repeat the experiment again, we can say with greater confidence, we can potentially expand this list a little bit more than an N of 1.
Okay. Are you, I mean, do you see Dave Drury regularly in person?
About every day or so, yeah.
So, I mean, he might be, yeah, he might be able to throw some light on this, whether these are surprising to him or not, I suppose.
Yeah, no, that's a good suggestion.
Because that
Could
is
you
a
get
pretty
these
nice result.
tested to see whether they're inhibitors?
Well, that's the thing, isn't it?
Yeah, I mean, we were just handed the compounds and we just profiled, and it actually was kind of good that we were blinded to what they are because we had no bias at all.
Yeah, I mean, if you see David, you could ask him about the possibility of that.
Okay, I will do that.
Yeah.
And I think we have the numbers, the actual, I mean, 26 and 28 aren't the actual numbers that these refer to. In fact, I'm sure they gave it to us. They were the ones that handed us the compound, so.
Yeah.
Yeah. All right, we'll check on that.
All right, fantastic. Yeah, in terms of the validation of the other targets you mentioned at the end, I mean, yeah, I guess it's a little more difficult, isn't it?
Well,
I mean,
they all make logical sense. Targeting fatty acid biosynthesis, targeting translation, these are all processes that are critical for bacterial growth. Whether or not, again, we'd like to be certain that these are really being hit. We would need some antibodies to validate that. And I guess that's something, I don't know if we have other, who the bona fide MRSA labs are on this, in this group, but that might be somewhere they can help us out.
could you just go to the targets that were hit there? I think it's the next slide.
Yeah.
Right, I guess we need to do a little bit of literature digging here.
Yeah, we can send you the accession numbers from the Excel sheet. That's sort of how I did some basic research on it. And I think did a little bit of Google searching to see if there was some potential connection to MRSA from.
Yeah, I mean, again, other labs are working on these that might be interested in checking out the compounds. I guess that's the first thing we can do, so that we're not duplicating any effort here.
Right, and the MNMA is clearly an ATP binder, so it would make sense why it might bind to these beads. The other two, it wasn't clear to me that there was a ATP or nucleotide pocket that might determine, although possibly there is something that would allow them to bind in a bead specific manner that would show competition. But yeah, in some ways I'd be very pleased if we find some new targets through this, because it's a challenge, right? With these are designed for kinases. If we capture things that are not kinases, then we can show competition. Ultimately, we're setting up in the lab here this thermal denaturation assay where we put compounds in and then we thermally denature to look for broadly, drug binders, but that's not set up yet. We've got a new person that's working on that. That's
Right.
what I'd love to couple this work with, but we'll see how soon we can get that set up.
Yeah, good. Okay, so I mean, we can definitely do some lit searching on that. If you're happy to do those 2 repeats experiment, that's awesome. And if you're happy to talk to David, that'd be great.
All right, we'll do that for sure.
All right, fantastic. Thank you. Any other questions on the data? All right, thank you guys. Really good.
Sure.
Feel free to stick around or leave if you've got
Yeah,
stuff
yeah,
to
no,
do.
I'd like to stick around.
Yeah, okay. We just, I guess, we were hoping to get just some quick updates on the next compounds that were coming through. So Daniel, did you want to lead off, just because I think you've already posted something about this that you could share?
I think I'll take off at this point. Thank you.
Great, thanks for coming.
Okay, so just 1 second, I'm gonna share my screen. Can you see my screen?
Yeah.
So based on the results from the compound 975, we designed some new analogs. Some of them we hope to improve the log-D. We get better log-D. Basically, the compounds that I highlighted here in blue, it's ready for biological assays. I'm having real problems to purify the compound 249. It's really complicated when I have the pyridine in the phenyl group, so the purification is getting a bit harder. But after 7 columns, sometimes I can get the pure compound. So I'm gonna work in this compound tomorrow. And the last one that I have, the CF3 and the nitrile group, I'm still waiting for the chemical. I bought from Apollo, is on demand. I hope I can get it this week because we ordered like 3 weeks ago. So I'm probably gonna finish the set of compounds this week or probably next week. So far I have those eight compounds for the biological assay.
Daniel, can I just ask how you're purifying 249, please?
Yeah. First of all, so I have tried many different ways. So first I was doing like normal phase. So after the reaction, the last step is the Suzuki coupling. I do like just a filtration through saline. Then I go for normal phase using chloroform and methanol. Chloroform and methanol is better than other solvents, so I try the other ones. Then for this specific compound, I use the column, the amino column. There's a biotage amino column we have here. It's a normal phase. So after that, I went for the reverse phase. The reverse phase, I use methanol and ammonium and water. So I got the salt of the compound. So, but it was not only the salt, it was a mix of salt of the compound and then also the pure compound. So the NMR was a bit messy. I did a workup yesterday to try to recover it from the water phase. But so far it's still in the water phase, even when I try to control the pH, because I was calculating the pKa. There are many different pKas because I can get protonation in 3 different nitrogens. So still my compound is in the water phase and I'm trying to work on that. For example, the other compound 246 that I have only the pyridine, I have done so far 7 columns. But the problem of this one is I always have start material together with the final compound. But basically what is working well is ammonium, 5% in methanol in water, and do a reverse phase.
Okay.
Because I was actually thinking about the Maria's compound. I was wondering if she got any problem to purify the compounds, because you added more nitrogens in the ring gas, so I was thinking about some problems to purify these compounds as well. I don't know if she could get any problem.
I ran the purification of one of these compounds several times. When I purified in a normal phase, I got 2 peaks because I had coelution, and then I ran.
Yeah, it's the 2 peaks. One is the compound and the other one is the start material.
Yes, and
it's
then
always together.
Again with the reverse phase, I used water and methanol, but the second time I did a very slow gradient, and I hope I got the compound because the LCMS is pure, but I have to run the NMR to see if I have really only the compound, but the LCMS looks good. So
what I have done, it's like I do like you, methanol and water. Then I collect, let's say, 10 tubes. So these 10 tubes, I need to run LCMS to check which tube I have the pure compound. Because even the LCMS sometimes, not the LCMS, like in the biotage, it's showing me just one signal, but then in the LCMS, some tubes are mixed, some tubes are pure, and some tubes are only the final compound. So it's better if you can run LCMS for all the tubes that you collect from the biotage.
I did like this. After the first 2 columns, I took the LCMS of each tube to see if it was the pure compound. So I hope to get the compound now.
Do you have the amino column, the one that I was explaining earlier? It's from
I think it's the KPNH column, right?
Yeah, that one.
We have those. I'm not sure that Maria is using that for this purification though.
No,
that one I use normal phase, like it's acetate and
but we haven't used that for this. Maybe in the interest of time, we should take this discussion offline. But I mean, we're more than happy to help you troubleshoot the purification of these compounds. It sounds like you're struggling quite a bit.
Yeah.
Can I just ask are 2-cyanopyridines stable?
Which one can you say?
2-cyanopyridine, is it stable?
With
It should
respect
be.
to-
Well, you can imagine a nucleophilic attack or SNAR type reaction, couldn't you?
Yeah, at least, for example,
With
I think
displacement of cyanide.
I haven't seen any side product so far
Okay.
for this one, but it can happen. Actually, this reaction takes 5 hours in microwave to complete the reaction, and I got only the signal of the final compound.
Okay.
I didn't see any side product so far.
Yeah. I just wonder if it can go to the pyridone.
Mm-hmm. Yeah. I will take a. I'm running the reaction again because after 6 columns, I don't have enough mass. So
Yes. Yeah, I can imagine.
I will take a look if I can check if there is any other signals. But so far, I don't remember to see any side reactions.
Okay.
What I mean, just to finish, I just changed the catalyst as well. So sometimes if you change the catalyst, you can increase the yield. Maybe we can discuss this. I can discuss with Maria.
Okay. Wonderful. All right. Thanks, Danny. Yeah, just in the interest of time, I just want to make sure that if Maria had anything to share that she could.
Okay. Thank you.
Yes, I have just one slide. Can you see my screen?
Yep.
Okay, so these are the analogs on which I'm working on. And particularly this compound should be ready. I have to check the purity of the compound and to see if the NMR is okay, but the CMS looks good. And then I'm working also on this compound, and I'm in the middle of the synthesis of the reaction, and I hope to have also this compound soon. So,
Just to add to this as well, we've also got compounds in the queue for the nitrogen scan of that left-hand piece, analogous to the compound in the dotted box with the purity to check on Maria's screen. Maria, can you point to that pyridine ring? Whoa. Yeah. Anyway, so those are coming through as well.
Okay, awesome. I think reading availability of people and the fact that we've got our, the chocolate holiday coming up, I think it's likely we're going to have the next round of evaluation is towards the end of April. I would guess, so sometime after the 20th. So on that kind of timeline, yeah, I mean anything that you can ship by approximately 20th or something is likely to feed in nicely to the next round of evaluation that we could do here. We can revisit that as we get closer, but it's something of that kind.
Sounds good. We'll keep you posted from our end as to when we're ready to send you maybe half a dozen.
Yeah, that'd be awesome. Yeah.
Yep.
Great. All right. Thank you. Perfect. Anything else anyone wanted to raise?
I did actually chase up Wuxi for the missing experimental from the beginning compounds. So I've actually, Matt and Ed, I just sent you the document so that you've got that. So we have that. And I also got their author names and affiliations for the publication. It's my intention to read that this week. I've been hoping to get to that for several weeks, but anyway. Hopefully this is the week.
Okay. Okay. And so yeah, well, we can take this offline, but Wuxi would like authorship for that, you think? Okay. Every company is different, right?
Yeah.
I mean, they were working with DNDi in the beginning to make those compounds. So they've said they would like to be included as authors.
Oh, good. Great. Great. I think it's important that we're really clear about that. So that sounds fine. All right. That's wonderful. Thank you for chasing that. Okay, if there's nothing else, then that's all good. We will likely regroup after Easter. So if there's nothing else, then have a great break and see you all again pretty soon.
Bye then.
Thank
Bye.
you. Bye.